viewers, I hope you all are doing great. Welcome back to our YouTube channel, The Engineering Projects. In this tutorial, we are going to discuss another feature of ESP32, that is OTA or over-the-air programming. OTA programming allows users to update their ESP32 with new program wirelessly or without using any serial cable. OTA programming is the mean by which the product manufacturer or the product service provider can update their products with new features wirelessly after the product has been deployed in the field. The key feature of this OTA programming is that only a single central node can send updates to multiple ESPs connected over a common network. But the condition applied is that all the ESP devices should be enabled with this OTA programming feature. Now let's move towards the programming part. Open the Arduino IDE. In Arduino IDE, we have some example code available for OTA programming in ESP32. To access the example code, go to File, then Examples, then this Arduino OTA and select Basic OTA. So this is the example code we are going to use. Now before uploading the code, let's have a look at the code description. So here we are using 4 header files or libraries. The first one is the Wi-Fi.h, which is responsible for connecting ESP32 to the internet. Next, this ESP-mDNS.h is used to provide the local network services. Next, we have this Wi-Fi UDP.h, which is responsible for sending the data to a UDP host over a wireless network. This Arduino OTA.h is used to enable the Arduino programming in ESP32. Now enter your Wi-Fi or network credentials, that is the SSID and the password. Next, inside the setup function, we are initializing the serial communication at 115200 baud rate. This Wi-Fi.mode function is used to set the ESP32 in station mode. This Wi-Fi.begin function is used to enable the internet connectivity in ESP32, and this function is passing these two parameters, that is the SSID and the password. This ESP.restart is used to reset the ESP32 module and tells SDK to reboot. Now this programming part represent the steps which are going to take place during the OTA programming, and if some error occurs, then that error will be printed on the serial monitor. This Arduino OTA.begin is responsible for initializing the OTA programming, and once the ESP32 is connected to the internet, then the IP address of the device will be printed on the serial monitor. Inside the loop function, we are using this Arduino OTA.handle to update program in ESP32 using the network protocol. So that's all about the code description. Right now our ESP32 module is not ready for OTA programming, so we have to upload our first code using the serial port. So click on this icon. But before uploading, make sure that you have selected the right development board and the COM port, that is we are using COM8 serial port. Now the code is uploaded successfully. Open the serial monitor. now you can see the IP address of this our device, and means the ESP32 is connected to the internet. So now our ESP32 module is ready for OTA programming. Now to test whether the OTA programming is enabled in ESP32 module or not, let's take another code. So this code is quite similar to the previous one, but the difference is that in this code we are going to make the inbuilt LED of ESP32 module to blink with a delay of 1 second. So here we are defining the GPIO pin number to which the inbuilt LED is connected, and we are defining an interval of 1 second to add delay, and the initial state of LED is low. And at the end, inside the loop function, we are defining the state of LED. So now let's upload the code, but this time make sure that you are selecting the network port. Click on this icon to upload, and now it is not required to connect your ESP32 module with your laptop. It means you can connect, but we just need to power on the board. And one more thing that we have to take care is that every time we upload a new code over the air, and if you want to keep the OTA programming feature enabled for future use as well, then every time you need to add this OTA enabling part in your code along with other instructions or adding different events. So now here we are sending an invitation to our ESP32 module at this IP address. Now you should see the inbuilt LED of your ESP32 module blinking with a delay of 1 second. So this concludes the tutorial. We hope you found this of some help, and also hope to see you soon with a new tutorial on ESP32. Till then, goodbye.